We import FastAPI and HTTP exception for the web framework and error handling, file response for serving HTML directly, Pydantic's base model for request and response validation, random forest classifier as our ML model, StandardScaler to normalize input features, NumPy for arrays, Unicorn to run the server, and OS for system operations. This initializes the FastAPI application with a descriptive title so we can define routes and handle HTTP requests. We define training samples where each row contains 3 features: attendance percentage, homework score, and exam score, paired with labels where 1 means excellent performer and 0 means needs improvement. We initialize a random forest classifier and a StandardScaler, fit the scaler on training data to normalize the feature ranges, then train the model on the scaled features so it learns from consistently distributed inputs. We define a Pydantic request model that validates the incoming JSON body, ensuring the 3 numeric performance metrics and the student's name are all present and correctly typed before prediction runs. We define a Pydantic response model that structures the API's output, guaranteeing the prediction label, confidence probability, recommendation text, and student name are always returned in a consistent format. This async post route receives a validated student data body, runs the ML prediction, and returns a structured prediction response. FastAPI automatically validates the output against the response model. We package the 3 student metrics into a 2D NumPy array and apply the prefitted scaler to normalize the values using the same scale learned during training, ensuring consistent model input. We run the classifier to get the binary performance prediction and extract the highest class probability as our confidence score. We map the binary prediction to a human-readable performance label and a tailored recommendation, encouragement for high performers and actionable guidance for students who need support. We construct and return a validated prediction response object containing the performance label, confidence as a rounded percentage, personalized recommendation, and the student's name. If any error occurs during processing, we raise an HTTP 400 exception with the error details, letting FastAPI return a structured error response instead of crashing the server. This async get route serves the school dashboard homepage by returning the index HTML file directly as a file response. This starts the Unicorn ASGI server on port 8000, binding to all network interfaces so the app is accessible from any device on the local network during development. Now here is our index.html where I have designed the all-user interface. If you would like access to this code, just send me a message on our Discord server.